reserved 100 examples for training purpose, and remaining 50 examples are reserved for testing purpose. Okay, this is a separate set. This 50 is not used during training, so this 50 is meant only for testing. Test data set also comprises of inputs and label. No, there is no difference between the test data set and the training data set. Input and target label. Okay. I told you that there is no difference between test data set and the training data set. Here we have 50 samples. And one important thing that you should remember is these two are distinct in the sense there are no examples which are common to both training and testing. And I mean you should not find an example that is there in both training and testing. Ronditlo same example undakodu. I mean there should not be any common examples between testing and training. In set theory, what we do is there should not be any overlap. There should not be any overlap. And if training set is A and test set is B, A intersection B should be 0. Okay, that is one thing you should remember. So during training, what we do normally, we give examples to the algorithm. One by one, we give examples to the algorithm, and we start with a model. Say we start with a model. Say y cap is equal to say w1 x1 plus w2 x2. Okay. In the previous class, we learned how we assume the weights of w1. Here w1 and w2 are known as, what are these two called? These two are known as, what are these two? Just recollect. These two are called parameters of the model. The parameters of the model are unknown values. Okay, you know, for a given example, you know what is his x1 value and what is the x2 value. You also know what is the actual value of the label. Okay, so in the previous class we learned how we assume the parameters initially. You can start with any value of the parameter, any values of the parameters. I mean, you can initialize the parameters with any random values. Okay. And when you initialize when you assume some random values for these parameters, obviously, when you use this equation to predict the blood pressure, whatever blood pressure that you predict, sorry for the interruption. There is a network problem from my side. Hope you are able to see my PDF document. Are you able to see the PDF document?
Yes, sir.
Okay. Okay. In the previous class, I told you how you can assume random values for all these parameters and how you can use optimization technique like gradient descent method to find out optimal parameters, because initially you assume random values for these parameters, whatever blood pressure that you predict, say for this case, this is y cap. Okay, the actual value is 92 and you have predicted 100, and obviously there is a error between actual value. There is a difference between actual value and the predicted value, and this difference is nothing but the error or loss. And you have learned already what are the various ways in which you can calculate the loss. And if you add loss for all the examples, you know that it gives us the cost of this particular model. Okay, and when you notice that the error is too high, what we do is assume that we are using batch gradient descent. So when we use batch gradient descent, what we do, we calculate the loss for the first example, loss for the second example, so on up to loss for the 100th example, and we accumulate all these values depending upon the loss function that you are using, and that accumulated value is nothing but the cost in the first iteration. Okay, I will use prefix instead of suffix. I will use suffix to represent the iteration number. So I will erase this suffix. When I say C superscript 1, I mean the cost that is calculated in the first iteration. Okay. There is something wrong with this. The cost that is calculated during the first iteration. Okay. Similarly, In the second iteration, what we do, again we take all examples in the training set. All 100 examples we give one by one to the model. And we ask the model, you predict the blood pressure for each and every example. And what is the difference between model in the first iteration and the model in the second iteration? The difference lies in the weights. We all know that in each iteration we update the weights. We update the weights or parameters of the model. Okay. In what direction we update? Do we increase the weights or do we decrease the weights? We calculate the gradient, and if the gradient is positive, we decrease. If the gradient is positive, what we do? We decrease the weights. If the gradient is negative, we increase the weights W1 and W2. So in the next iteration, again, in the second iteration, again we calculate the cost. Okay, still the cost will be very high. Okay, what we do, again we update the weights or parameters, update the parameters. Like that, how long this iterative approach or process continues? This continues until the cost is least possible, until the cost is least possible for the given training set. Okay, then whenever you have come up with optimal weights or optimal parameters for your model, you can conclude that your training phase is over. You can conclude that your training phase is over. Okay. So after training, normally what we do is we use the same model that we have learned after training to predict the examples in the test set. Okay. So now the inputs are given from the test set to the trained model, and the predicted values are recorded. So input is given from the test set and the predicted values are recorded. And whatever error you calculate, that is known as test error. Okay. The error that you calculate by using examples from the test set on the model that is trained on the training set is known as test error. And this error, whatever you calculate on the training set, is known as training error or train error. Okay. So here we use optimization technique to minimize the training error. Okay. And at the end of the training, we use test set which contains totally different problems or totally different examples to find out test error. If you are lucky, the train error and test error, if both are minimum, then we say that the learning phase is over, and whatever model that we have come up with after training, that model is fit for what do you call commercial purpose. Okay. When a model is fit for commercial purpose, if both the training performance and test performance, if both are high, in other words, if the training error and the test error, if both are low, we say that the model is what do you call, fit for commercial use. So can you see this comment in the box? Pick model that does best on test set. Okay, I would like to refer a familiar example in this case, or quote a familiar example in this case. Let us consider students as a learning model. Okay, so during training, what the teacher will do is, the teacher will give several problems. The teacher will take several problems and explain how the solution is arrived for each and every problem. Our solution is so one by one, during training phase, what the teacher will do is, the teacher will take problems related to, say, let us say you are undergoing training in Python programming. So the teacher will take problems one by one and he explains how to write programs for each and every problem. Okay. And if the teacher wants to know whether you have trained properly or not, what the teacher will do, the teacher will conduct, say, quizzes. So during the quiz, the teacher will give same problems that were taught in the classroom. Whatever problem is discussed in the classroom, the same problem will be given in the, what do you call, uh, evaluation phase. The same problem will be given. Say, let us say there are 100 problems in your curriculum regarding Python programming. Okay. Out of, let us say there are 150 problems in your curriculum related to Python programming. So I will discuss, or the teacher will discuss, how to write Python programs for 100 problems in the classroom. And the teacher will not show you the remaining 50 problems. See, in your curriculum, in your syllabus, there are, say, 150 problems which are to be implemented using Python. Okay, the teacher will take 100 problems for discussion in the classroom, and the teacher will never show, or the teacher will never give solutions to these 50 problems which are reserved for testing purpose. Okay. Now, because I have reserved 100 programs or 100 problems to be discussed in the classroom, what the teacher does is, he or she discusses one or two problems in each and every classroom, and at the end of the semester, or at the end of the um, term, at the end of the term, if the teacher discusses all the 100 programs, the teacher wants to evaluate, or the teacher wants to know whether you have learned properly or not. So what the teacher will do, the teacher will conduct a quiz which consists of problems from the same training set. The teacher will conduct a quiz which consists of problems from the same training set. And if you make any mistakes, In the quiz program, the teacher will identify those mistakes and correct you. So identification of the mistakes is nothing but finding the loss. Finding the loss means where your program deviates from the correct program. Finding the loss and correcting them or changing the errors. Okay. So like that, during training phase, you will be trained on the training set and you will be tested on the training set only. Training set only. Suppose a student has learned all the 100 programs which are discussed in the classroom. క్లాస్రూమ్లో చెప్పినవి అన్నీ నోట్స్లో రాసుకొని చక్కగా తరువుగా ప్రాక్టీస్ చేసి 100 ప్రోగ్రామ్స్ నేర్చుకున్నాడు. ఓకే, లెట్ us టేక్ an exceptional case. ఈ 100 ప్రోగ్రామ్స్ బై హార్ట్ చేశాడండి. సో వన్స్ అగైన్ I repeat, these 100 programs the student learned by remembering. Okay, now if I conduct a quiz program, he or she scores 100% marks because he learned all the 100 programs. And during training phase, you will be tested only on the training data, and the training data consists of only those 100 programs, and the student secures 100% marks. Okay, and once again I repeat, I assume that the student by hearts these 100 programs. Now during testing, I will give different programs. During testing, I will give different programs. Now those students who by heart the programs, do they perform well during testing? Do they perform well during testing? I'm asking you. If you simply by heart the programs during training without learning the programming, concepts, if you simply by heart, and during testing, if I give a totally different set of programs, what will be your performance in the test?
Bad performance, sir.
So you perform utterly bad. So your performance is very poor. Okay. So that is the reason why, even though your performance is very good during, there should always be a testing phase before you release the model into the market, where in the during the testing, the model is asked to predict previously unseen data. That is more important. Okay, during training as well as testing will be on the same data, training data. Okay, after training there should be a phase called testing, wherein the model is asked to predict previously unseen data. That is more important. ఇప్పటి వరకు మీకు అట్లాంటి ప్రోగ్రామ్స్ క్లాస్లో డిస్కస్ చేసి ఉండను. అట్లాంటి ప్రోగ్రామ్స్ టెస్ట్లో ఇస్తే టెస్ట్ కూడా బాగా రాశారనుకోండి, దెన్ యువర్ ప్రోగ్రామింగ్ స్కిల్స్ ఇన్ పైథాన్ ఆర్ గుడ్, రియల్లీ గుడ్. ఓకే, now you are fit to attend any interview related to Python programming. Okay, let us assume another case. The person has simply by hearted all the programs, because he has by hearted all the programs in the training data, and during training we will test only with the training data. His performance is 100%. He will get 100 out of 100 because he'll by hearted all the programs, 100 out of 100. Now if the same person is given, what do you call, a problem or a programming task which he has, which is not there in the training phase, which is not there in the training set, then he may not be in a position to write a program for that. Okay. So training, so if a model is to be selected finally, what is the conclusion? Training performance, both training performance and test performance should be high. Okay. Suppose training performance is high and test performance is high, then only we say that the learning is effective. And what is ineffective? You tell me what is ineffective? What is ineffective?
Without training, directly test data.
Please.
Ineffective, sir.
What is ineffective?
Without training.
So, no, not without training. Assume we are using only supervised models, supervised learning. So, training performance is very high and the test performance is very low. Training performance is very high and the test performance is very low. Okay. Then we don't say that the learning is effective. Okay. Now let us find out. Normally this ratio will be like this when there are only two phases of learning, training and testing. Normally for training purpose we use say 70 to 80% of the data. Okay, sometimes it may go up to 75%. So 75, sorry for that. 70 is, so the training set consists of 70% to 80% of the data. That is a variation of the data, quantum of data you have in the training set. So what is the lower limit? 70%. And what is the upper limit? 80%. For testing purpose, obviously the variation will be from 30% to 20%. Suppose if you take 80% of data for training, we take 20%, remaining 20% for testing purpose. So the given data set, which consists of both input and labels, should be partitioned into two disjoint subsets. The first partition should contain 80%, nearly 70 to 80% of the data, which is called training, and the second partition should contain around 30 to 20% of the data, which is meant for testing. Okay. I will explain one possibility of doing mistake here. Assume that in the data set, there are duplicates. There are duplicates. So if there are duplicates and if you haven't removed those duplicate values, it may happen that there are some examples which are available in both training set and test set. There are some examples which are available during training set and test set. In that case, a model, even though it hasn't learned properly, perform well during training as well as testing. ఎందుకు టెస్టింగ్ కి కూడా బాగానే పెర్ఫామ్ చేస్తుంది? Because some of the models in the training set are also available in the test set. So the model performance is not bad, but good during testing as well. So what is your conclusion in order to overcome that problem? What precaution you should do for testing? What precaution you should do while you form the test set? The test set is large enough. The test set is large enough to yield statistically meaningful results. Okay. Another one is representative of the data set as a whole. Is representative of the data set as a whole. What do you mean by this? Is representative of the data set as a whole. For example, if I train you on first 3 units of syllabus, so during classwork, if I teach solve problems related to first 3 units of the syllabus, and the last unit is not discussed at all during training phase, and during testing only problems from the 4th unit are given, then does that case satisfy this property? Is representative of the data set as a whole. What is your whole syllabus? Your whole syllabus comprises of unit 1, 2, 3 and 4. But does your data set contains problems related to first unit, second unit, third unit? No. It contains only, the test set contains only problems from the 4th unit. So it is not a of the data set as a whole. And during training, you should be trained on 4 units of syllabus, and during testing also you should be tested on all the 4 units of the syllabus. Okay. Let us take your okay, because there are 4 units in your syllabus, the learning model can be like this. X1 is say first unit, X2 is second unit, and X3 is third unit. See, W3 X3 plus W. So in this case, X1 refers to first unit, X2 refers to second unit, X3 third unit, X4 and fourth unit. W1 is the weight that you assign to first unit, W2 is the weight that you assign to second, third, fourth. Okay. And here the target is the marks that you obtain. And the predicted value is your predicted performance in the exam. Okay. So you can start with any model. For example, మీకు fourth unit నచ్చలేదు అనుకోండి, what you do, weight W4 is given 0. You don't want to read fourth unit, so W4 is 0. And you like the first unit more, so you give more weightage to W1. Okay. And you give less weights to second unit and third unit. So obviously your performance is not good. Okay. And the test set should be large enough. I told you already. So this is the most usual data set split. What is that? 80% training set and 20% test set. Okay. Assume that you performed badly in the during the testing phase. Okay. So again, you will be given a chance, course repetition. You will be given a chance to repeat the course, or there is a provision to go for a supplementary exam. So again, in during the course repetition, you will be given training. During the course repetition, you will be given training, and if I use same problems, if I use same test set problems again, when you write supplementary exam or course repetition exam, then what will happen? Previous testing phase లో ఏ ప్రాబ్లమ్స్ అయితే ఉన్నాయో అవే ప్రాబ్లమ్స్ రిపీట్ అయినాయి, ఏ సప్లిమెంటరీ ఎగ్జామ్లో కానీ లేకపోతే మన కోర్స్ రిపిటీషన్ ఎగ్జామ్లో కానీ. Then what will be your performance during testing? Your performance is high. So are you able to follow me? Whatever problems that are given in the regular exam, if the same problems in the regular exam are repeated once again in the supplementary exam, most of the problems are repeated, then what happens to your supplementary exam performance? You perform very well. Okay. And during training also you perform very well, because whatever problems are discussed in the classroom, the same problems are given during internal exams or during quiz. So your training performance is good and your testing performance is also good. Why your test performance is good? Because ఇది fourth time supply exam అనుకోండి, fourth time supply exam, and in all the exams the questions are keep on repeating. Then when you write fourth time your supply exam, your performance will be very good, because the same questions are given in the test. Okay. After 4 attempts, your training phase is good and your testing phase is also, your test performance is also good. Does that mean you secure a job? Because your final exam score is good and your internal exam score is good, does that mean you will secure a job? No. Because you haven't learned properly. During training, what happens? Whatever examples are discussed by the faculty member in the classroom, the same programs are given in the evaluation, training evaluation. Okay, you performed very well because the same examples are given in the training phase. And during testing also, first time you might have failed because totally different problems. And when you appear for the supplementary exam, because the problems keep on repeating, the problems in the test set keep on repeating. In the supplementary exam, you may get questions which were asked in the regular exam. Okay, so because the questions are same, then your performance may be good. Suppose if you neglected for first supply attempt, maybe during your second attempt, once again the same questions repeated. So your test performance is also good, final semester and exam performance is also good. So does that mean you will get a job? Means you are fit for doing a job in that domain? Will an employer will select you? No. The employer will not select you. So why the model failed? Why the model which has performed very well during training and testing failed utterly in the market, in the job market, or in the open competition? The reason is learning is not proper. Okay. So why the learning is not proper in that case? Because you have fixed the problems in the test set. ఫస్ట్ ఎగ్జామ్లో ఫస్ట్ టెస్టింగ్ ఫేజ్లో ఏ ప్రాబ్లమ్స్ అయితే ఉన్నాయో సెకండ్ టెస్టింగ్ ఫేజ్లో కూడా అవే ప్రాబ్లమ్స్. ఓకే, సో అందుకొని ఇక్కడ లెర్నింగ్ అనేది సరిగ్గా జరగల, అంటే వాట్ యు కాల్ మిస్లీడింగ్ రిజల్ట్స్ వచ్చినాయి. సో ఇది ఓవర్కమ్ చేయడానికి ఏం చేస్తున్నామనంటే వి కమ్ అప్ విత్ ఎ థర్డ్ డేటా సెట్. ఓకే, now this time we have training set, validation set and test set. Okay, after training you will be, your performance is evaluated with validation set only, with validation set only. Okay, and if your performance is not good, once again you will be given, ఇది చూడండి అండి, ఇది లూప్ అండి, సైకిల్. ఏంటి, initially you will be given training with the training set, and your after training your performance will be evaluated using validation set. And if your performance is not good during validation set, once again some model parameters will be adjusted, and you will be given training once again. So training phase, validation phase using validation set. If the performance is not good, okay, change the model parameters, and once again give the training. Assume that during validation your performance is good. It shouldn't. Pick model that does best on validation set. So you have, of all the models, suppose model 1, model 2, say model 10. Finally, you found that fifth model, model 5, has a good validation performance. So we select the fifth model. And in the final phase, then only we conduct the test. The problems in the test set will not be revealed more than once. And it's like, I think you are all familiar about this. Whatever problems that you get exam, I think all of you are familiar with advanced exam, which is an exam for entrance into IITs. So whatever problems you get in advanced exam, they will never repeat. Same is the case here. Okay. The test set is used to select the model finally. It's like an employer coming to the campus. It's like an employer coming to the campus, conducting an exam on Python, giving a totally different programs. Totally different means these programs which are given by the employer, say TCS or Infosys, you did not come across such problems during validation as well as training. ఇప్పటి వరకు చూడని ప్రాబ్లమ్స్ ఇక్కడ ఇస్తారు. Even then, during testing, your performance is good. Immediately, you will be selected for the job market or you will be offered a job. Okay. So in place of student, if you assume model, yes, the model is given training. The model is given training and the model is after training, we evaluate the model on the training set as well, on the same training set. We calculate the cost. Only training set మీదే మనం ఇవాల్యుయేట్ చేస్తే దాన్ని ఏమంటామండి? Training. We train the model in the train and we conduct the test on the training model only. అంటే ఏంటి? It's like a quiz. You will be given problems only from the training set. You will be given problems only from the training set. అంటే క్లాస్ రూమ్లో ఏమైతే ప్రాబ్లమ్స్ చెప్పారో అవే ప్రాబ్లమ్స్ మళ్ళా మీకు ఇస్తారు క్విజ్ అప్పుడు. ఓకే. అప్పుడు కరెక్ట్ ఆన్సర్కి మీరు ఇచ్చిన ఆన్సర్కి డిఫరెన్స్ ఫైండ్ అవుట్ చేసి లాస్ అన్ని ప్రాబ్లమ్స్కి లాస్ క్యాలిక్యులేట్ కంబైన్ చేస్తే ప్రాబ్లం 1, ప్రాబ్లం 2 ఇన్ ద క్విజ్ అన్ని ప్రాబ్లమ్స్కి లాస్ కంబైన్ చేస్తే యూ విల్ గెట్ కాస్ట్. Okay. Then what the faculty member will do? The faculty member will call you and the faculty member will correct any misconceptions about the concepts that are taught during training phase. సో ట్రైనింగ్ ఫేజ్లో చెప్పిన కాన్సెప్ట్స్ ఏమైతే ఉన్నాయో ఆ కాన్సెప్ట్స్ గురించి మీకేమన్నా వాట్ యూ కాల్ అండర్స్టాండింగ్స్ ఏమన్నా ఉంటే, if there are any misunderstandings, okay, then the faculty member will correct those misunderstandings. Okay. Once again, So correcting misunderstandings is nothing but changing the parameters of the learning model. So once again you will be given training. Okay. So at the end of the training, once again a quiz will be conducted. A quiz will be conducted, and if you perform well in the quiz, you say training is over, training phase is over. Okay, you have learned the weights properly. The weights are the concepts that you have learned, or the concepts that you have learned are sufficient for the training set. Then you will be given problems from the validation set which are not discussed during training phase. సో ట్రైనింగ్ ఫేజ్లో ఇవన్నీ ప్రాబ్లమ్స్ ఇక్కడ వ్యాలిడేషన్ సెట్లో ఉంటాయి. ఈ వ్యాలిడేషన్ సెట్ నుంచి ఎగ్జామ్ పెడతారు. ఓకే, యువర్ పర్ఫార్మెన్స్ ఈజ్ నాట్ గుడ్, వన్స్ అగైన్ యూ విల్ బి సెంట్ బ్యాక్ టు ద ట్రైనింగ్. ఓకే, this time you will be given some additional inputs. సే బ్రిడ్జ్ క్లాసెస్ కండక్ట్ చేసి ఎక్కడైతే ఏ కాన్సెప్ట్స్ అయితే మీరు నేర్చుకోలేదో ఆ కాన్సెప్ట్స్ కవర్ చేసి వన్స్ అగైన్ యూ విల్ బి సెంట్ బ్యాక్ టు ద ట్రైనింగ్. ఏ కాన్సెప్ట్స్ మీరు నేర్చుకోలేదని తెలుస్తుంది, వ్యాలిడేషన్ సెట్లో మీరు ఎక్కడైతే తప్పులు చేశారో ఆ కాన్సెప్ట్స్ మీరు నేర్చుకోలేదు. సో వి ఫిల్ ద గ్యాప్, అంటే వి ట్వీక్ ద మోడల్. వన్స్ అగైన్ యూ విల్ బి సెంట్ టు ద ట్రైనింగ్ ఫేజ్. సో ట్రైనింగ్ ఫేజ్ అయిపోయింది, ఇక్కడ క్విజెస్ బాగానే కండక్ట్ చేసిన, క్విజెస్ పర్ఫార్మెన్స్ బాగానే ఉంది. దెన్ వ్యాలిడేషన్ సెట్. ఓకే, ఈ వ్యాలిడేషన్ సెట్లో ఉన్న ప్రాబ్లమ్స్ రిపీట్ అవుతాయి. ఇంతకు ముందులో వ్యాలిడేషన్ ఫేజ్లో ఏ ప్రాబ్లమ్స్ అయితే ఇచ్చారో అట్లాంటి ప్రాబ్లమ్సే అవే ప్రాబ్లమ్స్ ఉంటాయి. సో ఇఫ్ యూ పెర్ఫార్మ్ వెల్ ఇన్ ద వ్యాలిడేషన్ సెట్, దెన్ you will be sent to the final testing phase. Okay, this testing phase is done only once, or the problems in the testing phase will never be repeated. Okay, so if your performance is also good in the testing phase, then we say that you are fit for a job. You are fit for a job based on your knowledge in this domain, say Python programming. Okay. So what final conclusion that I would like to give is, whatever problems that you come across in the test set will never be repeated. అంటే ఇంకొకసారి టెస్ట్ ఫేజ్కి వస్తే ఆ ప్రాబ్లమ్స్ సేమ్ ప్రాబ్లమ్స్ రిపీట్ అవ్వండి. సో హియర్ maximum filtration takes place. Only when you qualify training, evaluation during training, validation and testing, then only you are said to be fit for the market, for the outside world. Or in our case, then only the model is said to be fit for the what do you call real-time applications. I will stop here. If you have any doubts, you can ask me regarding the training set, validation set, test set. Okay, I haven't given the ratios. Okay, before I give the ratios, can you see this diagram clearly? Shall I zoom this? Okay, I will enlarge this diagram. Whatever I have taught in this class is summarized in this figure. same student, say student S1, approach A, maybe in this model the student has given more weights to first unit and fourth unit. Approach B, the student has given more weight to second unit and third unit. Approach C, sorry, ikkada. Approach B, the student has given what do you call equal weights to all the four units where the performance is for year. The student has given weights only to first three units and zero weight to the fourth unit. Okay, fourth unit is given zero weight, neglected fourth unit. Okay, here, okay, assume the student has neglected the third unit as well, only first two units is చదివాడండి, whereas here first unit to second unit to third unit. So model A, only first two units are given large weights and third unit and fourth unit are given zero weights. W3 is 0, W4 is 0, and W1 is 50.5 and W2 is 0.5. W3 is 0, W4 is 0. And model B, equal weights for all the units, 0.25, 0.25, 0.25, 0.25. Model C, say 0.33, 0.33, 0.33. Only three units are given importance and fourth unit is given a zero weight. W4 is 0. Okay. So model A got training from first two units only. Model B has trained or has focused on all four units, has focused on all four units. And model C has focused only on first three units. So when it comes to the validation set, the performance is 0.81 in this case, 0.92 for this model, and 0.86 for this model. Okay. Now, obviously, whichever model has very good performance during validation, that is picked. That is picked. And finally, that model is tested using test set. Okay. And if this performance is good, then this model B is released into the market, is commercially used. It is used commercially like that. So I hope you understood the evaluation that took place, evaluation that take place during training, during validation, during testing. And normally, it will be like this: 80%, 10%, 10%. So training, validation, testing. Okay, and it may vary slightly, 70, 15, 15. But if you look at validation and test sets, the proportion remains same. So whatever proportion you keep for validation the same proportion will be used for testing. So if 10% is reserved for validation, 10% of data will be used for testing, like that. So this is a ratio of various data sets for training, validation, and testing. So that is enough. If you have any doubts, you can ask me now. Any doubts? What I will do is I will give time because next class is on Wednesday. You go through the videos that are uploaded till now, or you go through the notes, whatever you feel like. And on Wednesday, I will revise all the concepts that are covered till now. Okay. So that will be the last chance for you to clarify the doubts that are covered so far. So after that, I will never once again, what is that, discuss about these topics.
సార్
So on, please.
సార్ మీరు అప్లోడ్ చేసిన ఫైల్ అప్డేట్ అవటం లేదు సార్ ఇది.
సో కొంచెం పెద్దగా మాట్లాడండి. కొంచెం పెద్దగా మాట్లాడండి. అప్లోడ్ చేస్తే
సార్ మీరు అప్లోడ్ చేసిన ఫైల్ అప్డేట్ అవ్వటం లేదు సార్, అది ప్రీవియస్గా ఫస్ట్ అప్లోడ్ చేసిందే ఉంది సార్.
ఏది నోట్సా?
ఎస్ సార్, మీరు నోట్స్లో ఫైల్ షేర్ చేశారు కదా సార్.
బట్ అది అప్డేటెడ్ అని అంటుందండి.
లేదు సార్, అవ్వలేదు సార్, నేను ఇందాక కూడా చూసాను సార్, అవ్వలేదు.
ఓకే, ఐ విల్ వెరిఫై. నేను ఐ థాట్ the already existing file will be replaced with the new one. Okay, I will check that. I will update the notes, no problem. Any other thing that you would like to share? So on Wednesday, I will revise all these concepts. So you better go through the notes or videos, whichever you feel like, and come up with doubts. As many doubts as you related to the concepts that are covered now. Ante. And మీరు ఎట్లాంటి డౌట్ అయినా అడగండి. నో నీడ్ టు హెసిటేట్. ఓకే, సో దట్ ఈస్ ఎనఫ్ ఫర్ టుడే. థ్యాంక్ యూ.